Okay, so we're continuing with particle motion problems with parametric equations. And you have seen from our homework that sometimes we need to figure out where a particle is, like what its position at a certain time, or what its plane curve looks like, the orientation, if it's clockwise, counterclockwise, and then applying some of our knowledge from other classes, like previously in geometry class, circumference of a circle, etc. So in this particular example, you guys already have the information from the do now, so let me just write that out. Okay, so particle A is given by this set of parametric equations, and particle B is given by this set. The two particles that are moving, particle A and particle B, are moving in the xy plane. So they would have different paths since they're different parametric equations, unless we somehow find that it gives us the same path. But we do know that it's for time that is greater than or equal to 0. So let's move on from there and see what's being asked. So in part A, it says to determine the exact time at which the particles collide. That is when the particles arrive at the same point at the same time. So we have to consider two different things here, okay? So if they're going to be the same point at the same time, that means that this point has to be the same. The x's have to be the same, and the y's have to be the same. So let's approach that first. So, A. We're going to set the two equations that equal to x together, equal. Okay? And so particle A and particle B, that's their x-coordinates. So if we solve this, we end up getting t is equal to 4, okay? And that's good. We have a time for where the x's are the same. So we want to make sure that we have the same time for where the y's are the same. So we're going to now take the y equations and set them equal to each other because it has to be in the same place. That means the x's have to be the same and the y's have to be the same, as well as the same time. So it should produce the same time if they ever collide, okay? So here we go. We go to solve this. Try to stick with my colored writing here. And this is going to have to be multiplied out into a quadratic and distribute the 2. Okay, and since it's a polynomial function, we should combine like terms. By setting it equal to 0 to solve, that's the goal in a polynomial, and I combine like terms. So here we go. We factor 2t times t will give you 2t squared. 6 and 2 give us 12, but that's not going to combine to give us a negative 11 here. So 4 and 3, 8 and 3 is 11. So set each factor equal to 0 and solve. So we end up with two solutions for t, and one of them does satisfy the problem. Both of these are when t is equal to 4. So we're rejecting this one. And so part A's answer is that it's when t is equal to 4 seconds when the particles arrive at the same place at the same time. And that was at, well, we'll see actually. When we actually sketch the paths, we're going to see the x, y. So let's move on to part B. So for part B, we have to sketch the paths of the particles A and B from t equals 0 until they collide and indicate the direction of the particle along its path. If you can't indicate the direction along the path, then write it out. Okay, that's your orientation, write it out. So I'm going to make up 2 tables. Okay. Now, I happen to know what these values are going to be for each table. And if I go up by halves, which would be the best bet when we're dealing with particle motion or parametric equations in general, it's going to be a lot of values. So I'm just actually going to cut to a few different values in my table for each. And that should actually be a 2 here. Let me fix that. Okay. So, or you know what? I'll make that an A, and this a B. Nice. Okay, so the first table, if I make t is equal to 0, I get negative 2, 4, and I'm going to cut to 2 and 4, and we can actually do 6, but this is going to give us a straight line, so we end up meeting at 4 anyway, and that's what it says until they collide, so I'm just going to stop right there. Okay, whereas the second table, we're going to have different values. Actually, I think A is the curve and B is the line. So let's see what happens when we actually plot this out. And we got to stop when t is 4. Okay. So we're going to set up our axes. Let me draw that out. Okay, so now that my coordinate plane is there, let's start plotting points. And I was right the second time. If we start plotting points for particle A, we can see it's following along a curve. Looks like a parabola. It makes sense. And if you did have those half increments, and even 1 and 3, we can see along the way that are coming down or coming back up, but we're still going from left to right. Okay? Just writing that here. Now let me take a different color and start plotting the points on the second table. Actually, this is up here. So when I connect it, it is going left to right. It is a line. So it's the same. Same orientation. So I'm putting an arrow that way. So it looks like they actually do collide when t is equal to 4 right here, where I actually put the arrows. It kind of looks like they collide over here, but what happens is it was not at the same time. This is where they collide. So I'm just writing some notes onto my graph. So it turns out that this point, negative 1, 1 that I plotted occurred when t is equal to 1 here. Okay, that would produce, when t is 1, that would give you negative 1, 1. Okay, but here it's t is equal to 2, so it couldn't have collided because they may have been at the same place, but not at the same time. Okay, only when t was 4 was it at the same place at the same time, so let me put in that point here. I just want to kind of finish that off. So t is equal to 4 seconds. They collided, and it was at 2, 4. Okay, tying everything together. That's it. Okay, good luck on some more particle motion problems.